the experiment that proved reality is not continuous. At first, it looked like a small inconsistency, a tiny mismatch no one expected to matter. Then that inconsistency refused to disappear, no matter how carefully it was ignored. And slowly, quietly, it began tearing apart everything physics thought it understood. To understand why this experiment changed reality forever, we have to return to a moment when physics felt complete. By the late 19th century, scientists believed the universe was smooth, continuous, and predictable. Energy flowed seamlessly. Motion followed perfect curves. Nature behaved like a finely crafted machine, uninterrupted and infinitely divisible. If something existed, it could be broken down endlessly into smaller and smaller pieces. At least that was the belief. This assumption shaped everything. Heat was treated as a continuous fluid. Light was understood as a wave spreading smoothly through space. Energy, like water, was expected to pour in steady streams. The mathematics worked beautifully. Predictions matched observations. Confidence grew quietly and dangerously strong. Then came a stubborn problem. When scientists studied how hot objects glow, the equations collapsed. Classical physics predicted infinite energy at high frequencies. Reality refused. Measurements showed sharp limits. Energy did not rise smoothly. It arrived in steps. At first, this looked like experimental error. Instruments were blamed. Techniques were refined. Calculations were repeated endlessly. But the result remained unchanged. Nature was not behaving continuously. Something fundamental was breaking. The experiment revealed a shocking pattern. Energy could only be emitted in discrete packets. Not any amount, not any value, only specific chunks. Between them, nothing existed. This was not a minor correction. It was a betrayal of intuition. If energy came in pieces, then reality itself was granular. Smoothness was an illusion. Continuity was an approximation. The universe was built from jumps, not flows. This realization arrived reluctantly. Even the scientists who uncovered it resisted its meaning. They treated quantization as a mathematical trick, a temporary fix, something to be explained away later. But nature did not cooperate. Every repetition confirmed the same truth. Energy refused to behave continuously. Light arrived in bursts. Atoms absorbed and released energy selectively. Reality was enforcing limits everywhere. What seemed like a technical anomaly became a philosophical rupture. If energy was quantized, then motion, matter, and time could not be infinitely divisible. There was a smaller scale, a fundamental unit beneath which reality would not go. The universe was no longer smooth. It was pixelated. This single experiment shattered centuries of assumption. It did not just adjust equations. It rewrote what existence meant. Because if reality was not continuous, then everything built on that assumption had to be reconsidered. And physics was about to enter a world where intuition no longer applied. Once the idea of continuity cracked, physics began to unravel at the edges. What looked like a harmless exception now spread everywhere scientists looked. If energy arrived in steps, then interactions could no longer be smooth. They were forced, selective, restricted by invisible boundaries no equation had predicted before. At first, this new picture felt deeply uncomfortable. Classical physics depended on continuity to function. Calculus itself assumed smooth change. Remove continuity, and the mathematical foundation trembled. Yet experiments did not care about comfort. They kept delivering the same verdict. Nature preferred jumps. Atoms became the next battlefield. When scientists probed how atoms absorb light, the pattern repeated. Atoms ignored most frequencies. They accepted only very specific energies. Anything else passed straight through. Matter behaved like a locked door that opened only for certain keys. This selectivity destroyed another assumption. Atoms were not miniature solar systems. Electrons did not orbit freely at any distance. They occupied fixed states, stable levels. Between those levels, electrons could not exist at all. There was no in-between. Reality allowed positions, then forbade everything else. The deeper this went, the stranger became. Electrons did not travel smoothly from one state to another. They vanished from one level and appeared in another instantly. No path, no gradual transition, just a jump, Physics lost its ability to describe what happened in between, because there was no between. This forced a radical reinterpretation of reality. Motion was no longer guaranteed to be continuous. Change no longer required a path. Events could happen without passing through intermediate states. The universe stopped behaving like a flowing river. It behaved like a staircase. Scientists resisted this conclusion fiercely. They tried to preserve continuity by redefining models. They introduced hidden variables. They searched for deeper layers beneath quantization. But every attempt failed under experimental pressure. Nature enforced discreteness mercilessly. Light itself joined the rebellion. Long understood as a wave, it now behaved like particles. Photons arrived in indivisible packets. Brightness changed by number, not size. Even electromagnetic radiation refused smoothness. Reality was counting, not flowing. This shattered the final refuge of classical intuition. If both matter and energy were quantized, then the universe was built from units, from smallest pieces, from indivisible actions. Continuity survived only as an approximation at large scales. The world you experience still feels smooth. Time flows, motion glides, surfaces appear unbroken. But that smoothness is a collective illusion. It emerges from countless tiny jumps averaging out. Beneath perception, reality stutters forward in steps. And once this was understood, a terrifying implication followed. If reality is discrete, then limits exist everywhere. There's a smallest action, a smallest energy, a smallest scale of change. The universe has resolution. Physics had not merely discovered a new rule. It had discovered the edge of what could happen at all. And beyond that edge, the old laws simply stopped working. As this realization settled in, the true conflict emerged. If reality moved in steps, then the universe was no longer fully predictable. Classical physics depended on smooth change to forecast the future precisely. Remove continuity, and certainty collapsed with it. The universe could no longer be treated like a perfectly wound clock. This was not just a technical inconvenience. It was a philosophical shock. For centuries, science had promised determinism. If you knew the present exactly, you could calculate the future exactly. But quantization broke that promise. When changes happen in jumps, the exact moment of change cannot be predicted. Only probabilities remain. This uncertainty was not caused by poor instruments. It was not due to human ignorance. It was built into reality itself. Between allowed states, nothing existed to measure. There was no hidden path to uncover. Nature offered outcomes, not trajectories. This forced physicists to accept something radical. The universe does not always explain how events happen. It only tells you what may happen and how likely each outcome is. Certainty was replaced by statistics. Prediction was replaced by probability. Knowledge itself gained limits. The smallest scales became inaccessible in a new way. Trying to measure exact values disrupted the system. Observation changed outcomes. Energy arrived in chunks too small to divide further. The act of knowing interfered with what was being known. Reality resisted inspection. This resistance was not malicious. It was structural. The universe was protecting its discreteness. Every attempt to force continuity produced contradictions. Every effort to smooth reality failed. Physics was being told, clearly and repeatedly, to stop asking for what could not exist. This tension split the scientific community. Some embraced the new framework reluctantly. Others rejected it openly. Einstein himself resisted. He refused to believe reality could be fundamentally random, yet experiment after experiment sided against him. Nature did not compromise. As quantum theory matured, discreteness spread everywhere. Time intervals, angular momentum, energy exchange. Even vacuum fluctuations occurred in quantized steps. The smooth universe vanished completely. Only layered probability remained. And yet, life continued unchanged. Objects still fell. Stars still burned. Clocks still ticked. The macroscopic world masked the microscopic truth perfectly. Discreteness hid beneath averages. Jumps blended into flow. This made the conflict even deeper. Reality was not what it appeared to be. Your senses lied beautifully. Beneath every smooth surface was a staircase of events. Beneath every motion was a series of jumps. Continuity survived only because scale hid the truth. Physics had reached a point of no return. The universe was no longer something to be traced perfectly. It was something to be sampled, estimated, predicted statistically. The old dream of total certainty was over, and once that dream collapsed, a final question rose quietly. If reality is discrete and probabilistic, then what does that say about causality itself? Does cause always precede effect? Or is even that relationship built from jumps? The answer would push physics into its strangest territory yet. The climax of the story is not a single equation or discovery. It is the moment physics finally accepted that continuity was never fundamental. Reality does not flow. It advances in steps so small, they disappear into experience. Once this was understood, everything changed. Space could no longer be infinitely divided. Time could no longer be sliced without limit. Energy could no longer be shared smoothly. The universe revealed a resolution, a grain beneath all structure. Below that grain, the questions themselves stopped making sense. This explained why nature felt both stable and unpredictable. Large systems averaged out the jumps, creating smooth behavior. Small systems exposed the truth, revealing randomness and limits. Certainty survived only where scale concealed discreteness. The universe was consistent, but never exact. This shift did more than reshape physics. It redefined what knowledge could mean. Science stopped promising perfect prediction. Instead, it offered probability, ranges, and likelihoods. Understanding became statistical, not absolute. Reality was no longer something to calculate fully. It was something to work with carefully. Modern technology rests entirely on this insight. Semiconductors rely on quantized energy levels. Lasers exist because electrons jump discretely. Quantum clocks measure time by counting transitions. The digital world is built on a universe that refuses continuity. Every screen you see depends on this broken assumption. Yet, most people never notice. The illusion of smoothness persists. Motion still glides. Time still flows. Surfaces still feel solid. But beneath that calm surface, reality clicks forward relentlessly, step by indivisible step. This discovery did not make the universe smaller. It made it deeper. It revealed that beneath intuition lies structure, and beneath structure lie limits. Limits that do not weaken reality, but define it. What began as a minor experimental anomaly became a permanent boundary on what can exist. The universe is not infinitely flexible. It is precise, counted, quantized, and once you see that, you never look at reality the same way again. The